This section examines the principles of the rotary engine. The rotary engine is not as common as the four-stroke or two-stroke engine, but its basic principle is well accepted. It operates very differently from a reciprocating engine. A piston engine is called reciprocating because the pistons move back and forth over the same path. This reciprocating motion changes into rotary motion at the crankshaft. A rotary engine has a rotor, not a piston, and it's called rotary because the rotor has a planetary motion. It does not reciprocate. The rotor is roughly triangular in shape, and it turns inside a housing which is a particular geometric shape called an epitrochoid curve. Because it spins rather than moves up and down, engine operation is said to be very smooth and vibration-free. Let's look at the basic principles of the rotary engine. The rotary engine does look different, but it's still an internal combustion engine. So let's find the 5 key events common to all internal combustion engines. Intake occurs when air-fuel mixture enters the working chamber at the inlet port. The turning rotor then carries it around to the spark plugs. Along the way, the volume of the working chamber decreases and compresses the mixture. The mixture is ignited and combustion occurs. Expanding gases produce a power pulse driving the rotor onward. When the exhaust port is uncovered, exhaust occurs as the rotor sweeps burned gases out of the housing, which brings it all back to the beginning, ready to run a new cycle. Let's look at the basic principles of the 4- and 2-stroke diesel engine. This is one cylinder of a 4-stroke diesel engine. This model uses what is called direct injection. It's an internal combustion engine with the 5 events common to all internal combustion engines. Let's see how they happen in diesel engines. Unlike the petrol engine, air alone enters the cylinder on the intake stroke. Compression, forcing the air into a small volume. This compression heats the air. At the end of this stroke, diesel engine fuel is injected into the combustion chamber. Ignition, burning the mixture. It's just the heat of the compressed air that ignites the fuel. That's why diesels are called compression ignition engines. Power, where energy released from combustion generates the force to turn the crankshaft. And exhaust, removing leftover gases. This brings the system back to where it began, ready for another cycle. Different diesel engines use different fuels. Fuel can be delivered to the chamber in different ways. Direct injection means fuel is injected directly into the chamber. The cylinder head usually has a flat surface, and the combustion chamber is formed in the piston crown. At top dead centre, there's very little clearance between the cylinder head and the top of the piston. Another method of injecting fuel is indirect injection. Fuel is sprayed into a smaller, separate chamber in the cylinder head. This chamber can have various designs. A glow plug is not a spark plug. It's a small electric heater that preheats the separate chamber as an aid to cold starting. It helps the combustion, which then spreads to the main chamber. Pistons in 2- and 4-stroke diesel engines can change directions hundreds of times a second and are exposed to extremes of heat and pressure. Modern pistons are made of aluminium alloys. Diesels using direct injection have an almost flat surface on the cylinder head, and almost all of the combustion chamber is in the head of the piston. Engines with indirect injection usually have pistons with a flatter head, and sometimes with small indentations. When the piston is fitted, there must not be too much clearance. It has to seal in the high pressures and temperatures generated by combustion. This is done by piston rings, held in grooves in the side of the piston. The top two rings are compression rings. The lower ring is an oil control ring. It scrapes excess oil off the lower cylinder walls. Let's look at the rotary engine's major parts. The rotor is mounted in an oval-shaped housing. The housing is made of aluminium alloy, but the curved surface has hard chromium plating. This surface has to put up with the wear and tear of the rotor sliding against it as it turns in the housing. There are usually two spark plugs fixed to the housing which enable combustion to occur. The rotor housing also has an exhaust port to expel burned gases. It has cooling passages for water to circulate. The rotor has three apexes which have seals to seal between the rotor and the rotor housing. This prevents premature wear as the apex seals and housing are in continuous contact. Side seals seal between the rotor and side housing. The combustion chamber is formed by hollows in the flanks of the rotor. These hollows are sometimes called bathtubs. Front and rear housings, or side housings, are bolted to each side of the rotor housing. If it's a two-rotor engine, there is an intermediate housing between the two rotors. An internal gear in each rotor meshes with a corresponding stationary gear in the front housing and rear housings. When combustion occurs, the meshing of the teeth forces the rotor to walk around the stationary gear. This combines with the eccentric shaft to make the rotor follow the curved surface of the housing, and it gives the rotor planetary motion. The rotor is attached to an eccentric shaft at points called rotor journals. This shaft is like a crankshaft in a piston engine, but with the journals off-centre. Because the rotor is off-centre, the force applied to the shaft is off-centre too. The whole shaft is supported by main journals, so the final output is smooth rotary motion.